Hi, everybody. My name is Nikita, and I'll be talking about isomorphic web applications in ClojureScript written with Rum. A little bit of background. I'm from Russia, from Novosibirsk, the city with a snowflake there. Most of my life, I've been writing web applications. Unfortunately, not in Clojure, so I've wasted a lot of time not writing Clojure. But eventually, about 4 years ago, I started to write Clojure. Again, web applications, server side, mostly. This was a time when I was happy. Then I switched to ClojureScript and front-end programming, and it made me not so happy, but it's still ClojureScript, and it's still fine. And yeah, now I'm building single-page web applications for web user interfaces in ClojureScript with Rum, which we'll be talking about. But to understand why this library exists, we need a little bit of history. The front-end development of the JavaScript world and the front-end web UI world is divided in two parts. So the first part is before React, is prehistorical times, and after React, which are modern times. The first version was released in May 2013, and it took some time to appreciate the idea and to adapt it in ClojureScript world. And the ClojureScript story of React and user interfaces really starts in December 2013 when David Nolan published his famous The Future of the JavaScript Frameworks blog post and released the first version of OM. So OM had three big ideas about how you should write front-end applications. It was that you should keep all of your state in a centralized place in a single item. You can use asynchronous rendering for optimized rendering, and you can leverage immutability to optimize rendering again. So this was awesome ideas, really nice, really influential, and JavaScript world later adopted them as well, and now React developers use them all the time, I hope. But that was interesting time because less than a month later, the first version of Reagent was released. It was called Cloact by then. And Reagent is also a ClojureScript wrapper for around React.js, but based on completely different set of ideas. So the ideas was that you have single small reactive atoms. You keep state in a set of small reactive atoms, and you build like reactive chain out of them. And when change something, it push the update through the chain, and then on the leaves you have your user interface. They also were first, probably, or I'm not sure first or not, but they used hiccup syntax for defining the user interface. And again, just a month later, so super interesting times, the third framework was released by Luke Vanderhart, released Quicksand. So this was slightly different. Well, again, it was very different. Okay, all three are really different. In that, the OM and Reagent were really big frameworks, well, kind of big. They had a certain opinion how you should manage your state. And Quicksand, it was out of the scope. It was really minimal. It removed all the object-oriented paradigms from React.js, and it was based on pure functions. And it was great and felt great for ClojureScript programmers, but it was so minimal that probably for real application, you kind of probably at some point will need them. So, but for small demos, it was really awesome. Rum arrived at this stage very late, and all three of these frameworks are great. They have great ideas, but still something was missing. This is a full timeline, just if you're interested. And the idea of Rum was that I really like all the stuff in all three of these main big frameworks, But I didn't want to commit to one of the idea and ditch the other, right? Because I didn't feel confident enough that I can decide which one of the models is really best and works best and completely ignore the others. So my idea was that all of these approaches and ideas are good, and probably we can combine them somehow, and probably we can use all of them when it's appropriate. So maybe in one application you have a place where it's best to use our model, but another place where the reagent model fits better, right? The real motivation that pushed me to write the library instead of just exercise this idea was that I wanted to use data scripts. So I was writing data script, and somehow none of these three frameworks wasn't compatible with that. So I decided to actually do a library that will work with that. But this is kind of small goal, and I decided to do something better. So DataScript isn't special, right? DataScript is just a kind of storage, and there are all sorts of other kind of storages. And again, I'm not sure that DataScript is the best we can have. Probably in the future, somebody will invent something better, or maybe in your case, local storage works better, or something else. So I wanted for my framework to support any kind of storage, not just pre-selected one. And the same goes with user interface models. I didn't want to commit to the three set of ideas that existing frameworks had, but I wanted it to be open to other ideas as well. Just as you see what works better for you, I wanted you to be able to use them. Okay, so solution to that is to write a framework that isn't opinionated and it doesn't commit to anything. What it does instead, it is built for extension. So whatever you think works better for you, you can take that model at that part of your application and use it, or you can write your own model and use that as well. It is actually not a framework, but a library, because by definition, framework is opinionated. Framework decides for you how your code should work and when it should be called and how it should be organized. Library instead is a small pieces of functionality that you decide when you need them and you use them when you decide to use them, right? There's no state model because again, I wanted it to be open to any kind of storages, but there are enough hooks to hook up any kind of storage that you want to, okay? And the idea was that if you build a library open for extension, it should have well-defined internals, and we should treat them as APIs. So in most libraries, there is private part and there is public part, and you're not supposed to look in the private part because it will be changed all the times. But and the developers of the library only promise you that they will not change the public API, right? But they change it anyways, but they promise they want to. But in Rum, there's idea that internals are important as well, and if you want to build something a little bit more complex than the basic application, I mean, you can totally use Rum without looking at internals, but if you want to build something custom, the way to go is to open up and read the code, understand it, and extend it because you see what's going on, right? So yeah, there is clear mapping between React.js and Rum. There is enough escape hatches. The code base is really small, and if you're building something with the average complexity or bigger, you're supposed to read the code. Okay, it's not that big, and it's well written, and it's very simple. And this is what we ended up with. So this is how Rum code looks like. The first two lines are define a component. There's devc macro, short for dev component, which kind of the same as dev function, but does some small stuff, some stuff behind the scenes. But still, it looks like dev function. Result of it is a dev function. So the result of devc macro is a function that works like any other ClojureScript function. Because it is a real function. And the idea was that if you're building a wrapper around React.js, we should make React.js simple, because React.js it's a framework, it's a mess, there's a lot of stuff that you can use to shoot yourself in the foot. And I wanted it to be simpler. Okay, so I decided, okay, yeah, obviously, and we're building framework for ClojureScript developers, so this should feel natural to use it from ClojureScript. So obviously, we decided on functions, not classes, on arguments instead of props. Use DOM as data as a Clojure. So you can see that hiccup syntax is a ClojureScript data structures representing virtual DOM. And two main ideas which are borrowed from React.js are state and mixins. Now, they do the same function as they do in React.js, but they are different. So there's Rum state and there's React.js state. And they're different, but they're supposed to do the same thing. Well, Rum obviously is better. Right? So mixin is just a map with lifecycle methods, and state is an immutable map with all the state you want for your component. And in React.js, state is a mutable reference that you can change at any time and pass around, which is a kind of terrible idea, especially if you're working in ClojureScript, where we know that immutability is good. And pure functions lead to simpler code and more robust code. So in Rum, state is there's local state for components, which is mutable, but you never get the hold of this mutable reference. You always get an immutable value of it. So you can only observe state. You cannot directly change it. Instead, what you have a set of predefined places where you can provide a function that will take old state and return new state, right? Pure function. Kind of the same way the swap works on atoms, right? You provide a function, and then somewhere inside the closure, your function will be called to change the value. So that's what's happening here. So for example, this function takes state and returns new map that is modified state. And the second concept is mixins. Mixins are just a set of lifecycle methods from React.js, like will mount, did mount, will update, deal update, and stuff like that. They are slightly different because they consist of pure functions, as I described before, which is really nice and makes its code more ClojureScripty. Yeah. And I just wanted to mention that turned out to be a very powerful concept. The mixins themselves, I mean, because everything. The idea is that the place where I work, Cognition, we are building single-page web application in Rum. We're building it for 1.5 years, and we've probably written about 20 mixins or something. And all the time when we wanted to do something crazy with our user interface, like JAX calls, drag and drop, or I don't know, all the complex stuff, it was always possible to express this as a mixin. So it turned out to really be a really nice concept. And all the stuff that comes with Rum, which is pre-bundled, also most of the stuff is implemented as a mixin. So there is local state. It is a mixin. There is a code that emulates reagent, quiescent, OM. They are all built as mixins. And so mixins are where you write this extension code for your components. And one of another cool feature of Rum. So this was before, it was always about front end in a browser, okay? But there are the cases when you want to render to your application on server side. This is done for search engine optimizations, and this is done for fast startup times for mobiles, for example. The idea is borrowed from the library called for OM. Alexander Solovyov initially implemented it for Rum, and then it was merged in the Rum core, and now it's official part of Rum. So the idea is that we have div-C components which are already in hiccup syntax, which is ClojureScript maps. So nothing JavaScript specific yet. Then we use Sablona to render that into virtual DOM, and then React.js converts it into real DOM. It looks like that. So if you have a component like that on the top, it will be expanded into something like that. So React.js class, blah, blah, blah. And if, so the idea is if we remove the bottom part and come from the same source that we have hiccup syntax, but directly render it into a string. So if we expand the same macro, but into something like that, a function that returns a string, basically, we will get a server-side renderer that doesn't depend on React.js or JavaScript engine at all. And this is hugely beneficial for ClojureScript and Clojure applications because usually when you're using ClojureScript, you probably will be using Clojure on a server. Clojure runs on JVM. There is no JavaScript context to evaluate React.js server renderer, for example. So if you can render the same components on a server using the pure Clojure code, it's a much simpler setup than bringing up Node.js or something. So that's exactly what we are doing in Rum. Okay, so we render to a string, we use pure Clojure implementation. You can share the same components you're using on the front end, but on the back end. If you put them in CLGC code, they will just work. It is sometimes faster than hiccup. So on a server, it works kind of like a hiccup. You have the same syntax, basically render to a string, so you can use it as a template engine. And there's actually one company that does that. But it really shines if you combine that with the front end. So if you use same components, you pre-render them on a server, you get the initial state of your application, then you pass it on a client and you start React.js there, it will actually be able to reuse that markup and start much faster. And you will be search engine friendly, and browser will be able to show you HTML before the JavaScript has even started. So server-side rendering, isomorphic web applications are possible with Rum pretty easily. So this is all. Probably most of the stuff that there is in Rum, that's it, right? Yeah. I've omitted some details, but mostly that's all. And what Rum is good for? So idea was that if you need some application where you need really fine control on how your rendering works, how your, I don't know, animations, state management or something like that works, it's better to use a tool that lets you have that, right? So in frameworks, it's because they are opinionated. Sometimes if you want to do something that it's not aligned with the goals of the framework, they just say, like, you cannot have that, we don't support that or something like that. In Rum, you always can do what you want. You always, yeah, that's basically it. And the second point, if you need to use some custom state model like DataScript database or local storage or something else, or if you want to mix a couple of storage models, it's totally possible in Rum. Nothing prevents you from doing that. And actually, in our application, we use DataScript as a main storage, and we use a couple of reactive items for stuff that we don't want to put into DataScript. And it works really well. There are components that, for example, depends on both sources of data, and it works fine, right? And the third point, if you need to render on server-side rendering, for example, if you need your application to be search engine friendly, or if you're building mobile application, you probably need a server-side rendering, and you can have it with Rum. What it's bad for? So the only disadvantage of that approach is that when you build a not opinionated framework, it doesn't help you to start. If you're first time writing a client-side application, you can do anything with Rum. You can have any model, and you can have any architecture you can think of. But it doesn't help you to start because you don't know what your options are, right? So in that case, it's better to start with some framework that has a clear structure, that has it all figured out. It will just help you. Or maybe you should read some, I don't know, articles about how the web applications can be structured. There's Reframe, for example. It's a library, but you can also read it as just an architectural guide. And yeah, don't use RAM if you want a clear path from start to finish where everything has been figured out for you. But if you want fine control, if you know what you're doing, RAM is perfect for you, I think. That's it. We have GitHub repo, obviously. We have support channels. You can always ping me directly. That's it. Yeah, that's what I have. Questions, please?
Thank you for the great presentation. I'm curious about this design goal of integrating it with DataScript. I'm only basically aware of DataScript, but can you explain a bit further how the Rum model opens up connectivity to DataScript that the other models doesn't do?
So the idea is that, okay, you can use DataScript as if you're using top-down rendering all the way down, so you have a database on the top, and if it changes, you render everything. This is fine, but not very efficient model. And you can probably have that in other frameworks as well. It's not that hard. In Question totally you can have that. But if you want, for example, something like reactive queries, or something like monitoring transactions and only re-rendering parts of your application that are dependent on parts of DataScript, not the whole database. So DataScript is a big database where you keep everything, and you want to, sometimes you want to keep track only of changes in the parts of them, not the whole database. If you want to do that, you can set up a set of listeners on DataScript database, and then you can connect them with components that should be updated based on that. So it's not like you can have that as a library, as a solution, ready-made solution. It's not there yet, at least. But you can totally implement that yourself. So because it depends on what exactly you want to keep track of, how your database is structured, and which components you want to update. It's it's very entangled with the logic of your application. So sometimes it's even better that you implement that yourself rather than use like relied solution. So basically the idea is you set up watchers and you can connect them directly to the components that need to be updated. That's it.
Thanks.
Okay, seems like no more questions, so thank you, Nikita.
Thank you.